What's going on, everybody? Today we're going to be going over macromolecules. Before we get into macromolecules, what is a macromolecule? Well, these are essential molecules for life. And we're going to have 4 of them that you'll cover in biology, your basic biology, and your honors biology. You're going to have your carbs, your lipids, your proteins, and your nucleic acids. You've probably heard of your carbs and your proteins. You might not have heard of lipids or nucleic acids before, but we'll get to that in another slide. A thing that you're going to notice with all macromolecules is they all have carbon. The carbon is extremely important to these molecules. Why? Because they can make up to 4 bonds. 4 bonds gives you unlimited possibilities. Like imagine hydrogen, right? Has 1 bond. Imagine you would just have a hydrogen chain if you just built your macromolecules all out of hydrogen. Granted, you know chemistry, so if you don't know chemistry, you're probably very confused, and rightfully so. But carbon makes 4 bonds, can bond 4 on 4 of its sides, and that just allows for it to branch out. Like as you can see, like I don't know, here in the protein area, like that carbon is just like 4 areas it's bonding to. It's crazy, and it's just gonna allow for all those branches to be made. We're gonna have monomers and polymers. These are 2 terms that you need to know. Your monomers are gonna make up polymers. A good way to think about this is a monomer is a building block, We'll get to another slide that has an example of what that really means with Lego bricks, but just think about it like you need the monomers to make the polymers. Like if you notice in this graph here, I know it's a little blurry, so sorry about that. You have your monosaccharide and your polysaccharide. You also have disaccharide. That's a polymer, but we'll get to that later when we get to all the examples. But you have your monosaccharide, and that's going to be just 1. Like, for example, carbs have monosaccharide 1, sugar, saccharide meaning sugar, mono meaning 1. And we have polysaccharides, multiple sugars. But yeah, for the example, we have the Lego bricks, like I was saying. You need the monomers to build the polymers, right? These are your single base units. These are your multi-built, insane structures. But how do we build monomers into polymers? Well, we're going to use a reaction called dehydration synthesis. Dehydration meaning remove water, synthesis means to build. Put it all together, remove water to build. That's how you should view dehydration synthesis if that vocab does not make sense to you. So as you can see in the graph, we have 2 glucose molecules. These are monomers. These are monosaccharides of carbs. And as you can see, again, if you don't understand monosaccharide, like carbs, all that, we'll get to that later. That should be some of the next slides coming up here. But as you can see, it highlights where that H2O is. There's a presence of a hydrogen and an oxygen. Oh, gotta go back. We're going to remove the water. So as you can see the reaction, there's a little arrow pointing down saying that, oh, we're getting rid of the water. It's going bye-bye. It's going to bond it together, and that O that's left on this side of the mono, if you can see my mouse, that O is actually going to bond the 2 together, and in this case, the 2 glucose are going to make maltose. How do we break the polymers together? Just think of it in reverse. It's called hydrolysis, and if you don't want to think about the big vocab, I'll break it down for you. Hydro meaning water, lysis meaning to break apart. Put it all together, water to break apart. So remember in the last example we had the maltose at the end, that single oxygen being bound together. Well, we're going to re-add H2O water back into the equation, and look, we have 2 glucose molecules again. So they're literally reverse of each other. So remember, breaking polymers into monomers is hydrolysis. Building monomers into polymers is dehydration synthesis. So let's get into the 4 macromolecules I stated before. We have carbs up first. These are going to be your quick, immediate energy sources for the cell, minus polysaccharides, which can be used for long-term energy. You're going to see these made of carbon, hydrogen, and oxygen with a ratio of 1 to 1. So you're going to have 1 carbon, 2 hydrogen, and 1 oxygen. So for example, glucose is 6 carbon, 12 hydrogen, 6 oxygen, for example. So you're just going to see that ratio of atoms in, brain fart, in your carbs. You're going to see these molecules are very distinguishable by the ring structure. So if you look at this monosaccharide up here, we have that ring-like structure, and then it's also going to have the -ose suffix at the end. Again, the monomer is monosaccharide, and your polymers is like, for example, your disaccharide, your sucrose, and your polysaccharide, amylose. And just know, this is an important vocab word, saccharide means sugar. Like when I first learned macromolecules, I'm like, what the hell is a saccharide? Well, saccharide is literally just sugar in fancy science lingo that makes absolutely no sense. Next up, we have lipids. Lipids are used for storing energy, and just so you know, they are hydrophobic. Water resistant is what that means. Basically, like if you ever done an experiment where you had water and oil in the same thing, you know that they'll separate, and this is hydrophobic properties of the lipids being shown in that lab. So much like carbs, they're actually going to be made of the same compounds of carbon, hydrogen, oxygen, same ratio, 1:1. But your monomers are going to be glycerol and fatty acid chains. So if you look over at the diagram here at the bottom, you're going to see your hydrogen-bound carbon bound to these long chains, and that's going to be your fatty acids. You put 3 together, and you get the polymer triglyceride. So as you can see here, we have 3 glycerols bound to 3 fatty acids. That's triglyceride. Glyceride is literally glycerol and fatty acid put together, tri meaning 3. So yeah, you get your triglyceride. There's a big difference that you need to know. You will get tested on this. Saturated fats and unsaturated fats. So unsaturated fats, you're going to notice, are going to have this little bent shape. Don't ask me how that happens. I have no idea. But on the vice versa, we're going to have the saturated fats, which are just going to be straight across. No change, no bent, no nothing. Okay? And you may be asking, like, oh, this is starting to make a little more sense. Like, I always hear from people that I shouldn't be eating saturated fats, and this is why. Saturated fats are not good for you because they're in that straight. They take more energy to break apart, and your unsaturated fatty acids are going to be easier to break because they're bent, they're weak. It's easy to break apart. So next time you go to the grocery store, now you know, or maybe you already know, and for that, I applaud you. You're smart. Give yourself a chocolate sundae. I don't know. But another thing to note is these make up your cellular membrane. The top picture here is kind of a drawing visual of that. So next we have proteins. These are super diverse macromolecules. They have a lot of functions, such as transporting oxygen, providing structural support, even being enzymes, like doing the whole enzyme thing. If you don't know enzymes, go check out my other video. So unlike carbs, these things are made of carbon, hydrogen, oxygen, and nitrogen. That nitrogen you're going to see in the amino group here. If you look at my cursor, nitrogen right there. Your monomer is going to be your amino acid. There is 20 kinds of amino acids, and they're all distinct by the R chain. And if you look on the thing, you don't need to know the carboxyl group. You don't need to know the amino group, but you need to know the R group. The R group is the distinguishing factor between amino acids, and there's 20 kinds. And when you put these amino acids together, if you look in the diagram, you get these little long snake-like chains called polypeptides. Woohoo! They're cute. They're cute. They kind of look like you ever go to like an arcade? I remember this at Chuck E. Cheese one time. We got these long candy bracelet necklace things. They were awesome. I just eat the candy and then I'd look stupid. Anyways, moving on. Nucleic acids, these are going to store your genetic information. You've probably heard of DNA and RNA, but we'll get to that later. So unlike all the macromolecules, it's going to have carbon, hydrogen, oxygen, nitrogen, but then we're also going to have phosphorus. It's going to act as a base, I believe. Maybe I'm just a little stupid. But your monomer is nucleotides, and when you get to ATP, the energy for the cell, you're going to really understand nucleotides. But over here we have the phosphate group, a ribose, and a nitrogenous base. That's going to give you your nucleotides. Put many of those together, and you get DNA and RNA. DNA being the double-stranded one. You're going to get to this when you do... let me think. DNA replication, mitosis, meiosis, all that shit. Whoa, language, I apologize. DNA, you're going to see here, RNA. You're going to see coding proteins, I think, right? No. Man, it's been a while. Anyways, DNA, just know, stands for deoxyribonucleic acid. I think that's how you say it. And ribonucleic acid for RNA. But like I said, just to recap everything we said here, stores genetic information. Your monomer is a nucleotide. Your polymer is DNA and RNA. And that's going to be it, guys. If you guys did enjoy today's video, please drop a like, maybe subscribe if you're feeling up to it. Check out my other videos if you want to get some further understanding of these biology topics that you might not understand 100%. I try to make these videos a little bit fun. You know, nothing's fun about learning. For a lot of people, I love learning, but you know, you might not like learning, and that's okay, and you just want to really pass your biology class, and I understand that. So anyways, you guys have a wonderful rest of your day, wonderful rest of your night. I hope you guys aren't up too late studying for this biology quiz or whatever you're taking. So anyways, have a good one, guys. Adios.